So when we're looking at these growth and decay models, and we get into something, oops, let me get that out of the way, that's a little more in depth besides just plugging in the R value and knowing what everything is already, like number 5 is here. So doctor prescribes a medication for our allergies. Okay. After each 1 hour interval, only 90% of the medication present 1 hour ago remains in your system. If you take a 100 milligram tablet, in approximately how many hours will only 50% of the medication remain in your system? Okay. So in how many hours is 50% going to be left? So I've got to look at this and say, okay, what are the parts for me to figure out what the actual expression is going to be? So I look at this and go, okay, do I know what's left? Well, no, not yet. So get my y equals in here, because I just use y. I know sometimes they use a and they change it all around, but y is just a little bit simpler to use. So do I know what I started with? I do. I started with a 100 milligram tablet. Okay, so that's my a value. This is the part that gets a little more interesting, and where we're going to talk a little bit about a growth or decay rate versus a factor. After each 1 hour interval, 90% of the medication remains. They're telling you how much is left. They're not saying, it's 1 plus or minus 90. That's the actual factor. So 0.90 is what I'm going to be putting into the parentheses. You're like, well, now how am I supposed to tell when I should do 1 minus 0.90 versus just using 0.90? And the basic thing I've got to tell you here is you've got to use a little bit of common sense. After each interval, 90% remains. That's what's left over. So I know if I do minus 90, well, then only 10% is going to be left. That doesn't make sense. So there are some keywords that I kind of have to look at to see what's going on. And then again, the time I'm going to use in general, because again, this value as I go through here is going to change that each time. So if I look at this, let me pop the calculator up, because there's a couple of things I can do to make sure that this goes a little bit simpler for me. So if I go ahead and I get this plugged in, and again, I know it keeps talking about 1 hour, that's my rate, but I want to do this over time. I'm going to look at my graph just to kind of be curious. I'm like, I can't see it. Okay, let's look at the chart. Now let's see if this is sensible. And it is, because I started with 100. After an hour, 90% of 100 is left. 90. After 2 hours, 81 milligrams is left. You're like, well, how am I supposed to know if that makes any sense? Well, think about it for a minute. If after an hour you had 90 milligrams, and then after another hour you're going to have 90% of that, you just do 90 times 0.90, which is 81. That's where this is coming from, and so on. So you can look at the table to kind of see if it's making sense or not. Once you see that it does, I'd go ahead and I'd get these filled in. Get my cursor out of the way here. Yeah. Most of the time what I'll do with these, and the question is, what do we round to? I usually will go to a 10th unless I'm told specifically go to a 100th or a 1,000th or something like that, but I'd never mark it off if you were more specific than I was asking for. As my calculator disappears. It's 59. 53.1. I'll move my calculator here in just a second so you can get those last values down. Let me shrink that down. So I get my values in here just to kind of see how this is working out. But the question itself is, about how many hours does it be till half the medication's left? Well, basically I look to see, okay, at 6 it's 53.1, at 7 it's 47.8, so the 50 is somewhere in the middle. So somewhere between 6 and 7, okay, to kind of get an approximation of where that would be. And that's basically how I have to tackle these. I've got to make up the expression first to see how it works. So you're like, okay, this may make some sense, but let's kind of look at some more here. So let's scoot down and look at 6 and see if anything changes. So I look at 6 and it says, okay, you invest $5,000, there's my A value, in an account that earns high interest at an effective rate of 8.4%. Rate is 8.4% per year. In how many years will you have over $6,800 in the account? Okay. So I started with 5,000. I have a rate. Okay. Notice it doesn't say after a year you'll have this much in the account. So this is one where interest, of course, is helping us, so it's growth. So I'd put in the plus, and I'd look at it that way. Now, here again, common sense, I'm going to keep saying rules the day with things like this. Because I go ahead, I'm going to plug it in the way I've got it written here. And I'm going to look at my chart. Now, it's sensible when we're earning interest that the y value is going to be going up. If for some reason maybe you put minus and it's decreasing or decaying, you need to get your money out of that bank. That's kind of scary. But, or again, maybe if you did it and you just put 0.084. Okay? Now, think about this for a minute. Let's say you would have done it that way. You did it and you kind of treated it like the last one. And you're like, well, I'm just going to put the 0.084 in and do it that way. Well, hopefully you'd look at your chart then and go, oh, after a year I'm going to have $420 left in my account that I had $5,000. That makes no sense. So sometimes it can even just come down to saying, does my answer make sense? And if it does, well, super. We're glad to hear it. Oops. But if not, I'll go ahead and get my chart back up here. So I can go ahead and get this filled in. Now again, when you're doing these, you can get a more accurate value if you wanted to go really far out, because you'll notice like on my 5875, the calculator will round it to 30, but if I'm going with what I see right here, it's at 28. That's one of those minor rounding things that I'm not going to nab you on. Because my goal is to make sure and see that you get what's going on. Not that we're rounding to the correct perfect cent here. Just swing over here. Behold the power of compound interest. So just like before, when are we going to have over $6,800 in the account? We don't here in year 3, but in year 4 we do. So somewhere in between, and probably a little closer to that 4th year because we're closer to this. So even if you wrote almost 4 years, that's fine. Not a big deal whatsoever. Now kind of comes our graduate exam here on dealing with these. Last one, move this down a bit. All right, after 2 hours, whoa, only 75% of a new medication remains in your body. If you take an 80 milligram tablet and this rate of decay is constant, in approximately how many hours will less than 15 milligrams remain in your system? Okay. Let's look at the parts here to see if we can figure out how this works. So you're like, okay, so after 2 hours, 75% remains in my body. Now here's the problem. I can't use that 75% as my factor. Like we did up above where it said 90% remains. You're like, well, why not? Because it says after 2 hours. Do I know for sure that it was constant over that time? That it was like 12.5% each hour? I can't assume that. So here's what I'm going to have to do instead. We know it's decay. So now we basically got to look at this and say, okay, what pieces do I have that'll make this work? So I look and I'm like, okay, well, what do I know? I know A is 80. I'll move this out of the way so we can get some more room to work with here. What else do I know? In this case, since it tells me the time, 2 hours, I actually know the t-value this time. Okay, and it's not talking about it being a consistent rate, so I don't know otherwise what that is. And I actually, this time, I'm going to know what's left over. My y value, it says after 2 hours, there's 75% of this left. So my y value is 75% of 80, or 60. You're like, but I don't know what r is. You're right. I have to find it. So what I'm going to do is I'm going to plug the other values in that I know. And I have to figure out what r is going to be, because then I can plug in the other info like I've done on every other problem. So this is going to take a couple of minutes because I can't just plug this into the calculator. So I look, I'm like, ew. What do I have to do here? I need to isolate r somehow. Where should I go first? What should I do first? Yeah, we've got to divide by 80. So when I divide by 80, you're like, hey, there's the 75% again. Amazing how these things come back around like that. Okay, now what? Yeah, we got to get that squared off of our 1 minus r so we can actually get at the r. And the square root of 75 hundredths. Okay, now again, don't go crazy here. Even if you went to 0.87, that'd be okay. It'd be slightly different from what I've got, but that's okay. And I could go ahead, minus my 1 over and find my r value. And you're like, okay, well, that was good. I'll put 0.134. Whoa, 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 whoa. You're not quite there yet. Like, dang. The last part, then, to actually find out how many hours it would take for less than 15 milligrams to be in your system, now that we know our r value, is again to take my A, its decay, and that's my rate now. Once I have that, now I can use the calculator to try and see how much or when that's going to be available. So I'm looking for less than 15. So it's going to be about 11 to 12 hours, somewhere in there is where that's going to be available. Now, am I going to pound you with a bunch of problems like this as we're going forward? No, but I want you to see that sometimes, depending on the information, you have to think a little outside the box to kind of play around a little bit. But most of ours are going to be more like what 5 and 6 were up at the top. So I just wanted to make you aware of that.